got a flute, huh? That's so random. Okay, let's see what feature is talking about.
Most people fail to learn Rust because they try to understand the hardest Rust concepts in isolation.
Macros. I don't understand macros.
But in real production
Unsafe, of course. Unsafe Rust is.
Rust, these concepts show up all at once. These few lines of Rust code are proof.
What's happening here? We have a main Tokyo main macro, which is basically going to expand into a main function that returns a pinbox line thing or other, yeah. And then you have a sleep new. Sleep is probably from Tokyo. And you're getting it there and doing a wait, fine. Oh wait, no. You have implemented sleep. Sleep is like a custom struct they've done where they've implemented pose. Oh, this is something I don't know. This is very exciting. This is one of the projects I wanted to do to really understand how an event loop works to build something like Tokyo. And I remember there was some video where somebody actually did that in like a 20-minute video, like a toy version. This is basically that, I guess.
This is essentially how Tokyo's sleep works under the hood. And packed inside this tiny example are macros, async functions, lifetime parameters, and unsafe Rust, all colliding together. So in today's video, we'll deconstruct this code snippet so you can internalize the 4 hardest Rust concepts in only 10 minutes. So grab a notepad, get your popcorn, and let's dive right in. This video is presented by the Rust Live Accelerator. And today we're officially opening applications. More on that later. First, let's set the stage and just understand high level what this code is doing. Our sleep feature is doing one simple thing. It periodically checks the clock. If it's too early for the set duration, it comes back and checks again later.
Makes sense.
On top, Tokyo main is a macro, the first of the 4 hardest concepts in this file. A macro is code that writes code. Its whole purpose is to kill boilerplate.
I mean, yeah, I know it's bytes in, bytes out, but how are you going to explain this right now? Because Tokyo is like very complicated.
Instead of handwriting the same setup every single time, you can capture it once and reuse it with a single line.
Oh, Vim macro. Actually, that's a really nice way to understand it. A macro is basically a Vim macro, right? For those of you who don't know what I'm talking about, you can go here and I could basically create a.txt, and I'm going to. So go here, I'm going to put a few names. I'm going to say Ashu, I'm going to say Prime, I'm going to say Teach, I'm going to say Akansha, Shivam. There's some random names that came to my mind. Nakshatra. Okay, cool. So I have this stuff. Now, of course, I could go here and I could say, if I want to say my hello, I'm my name. Nice to meet you, right? So one way is to do this. I can do this. I can insert hello. I'm gonna make it bigger. Hello. Right? Then I can go to the end. But now if I want to do nice to meet you, what I have to do is, okay, I can't really do this, right? I can't do nice to. That's just gonna do that. That doesn't work. So one option is put some spaces. So it already breaks down here. So then instead, what I can do is I can record a macro where I put I type hello, I put comma, I go space, I go escape, I go one word next. Sorry, that's too much. Go back, end of the thing, and I say dot, nice to meet you. Alright, and I go to the next line. Sorry, I go to the next word, and then I quit recording. And then I can just run this macro 5 times. I do 5 at a, right? No. I do add a. You get the idea, right? I can just re-record this stuff right here. So this is a macro. I just recorded it and then I replayed it. So that is something that Rust lets us do within the language, right? That's a good way to understand.
And here's the key thing about macros. They are hard to write, but easy to use.
Yeah.
Writing one means writing a program that generates correct Rust code for every possible input, which is genuinely difficult.
Okay, web macros are hard, easy to record, hard to use, I guess.
But using one, like we are here, is simple. Let's unpack what this single line does for us. This is what the Tokyo main macro expands your
Okay, Tokyo Runtime Builder. Okay, fine. No, I thought you would go through all of this. This makes sense.
code into. It
Block
builds a
on,
multi-threaded
block on.
runtime
Block
and then runs
on.
your async function on top of it. You wrote 3 lines and the macro generated 10.
Rust
Now
is
let's
very-
head back
it
to
is
our
very-
original code.
It's a very fond taste in your, I love Rust.
Right below the main macro is async function main and sleep new, which are both async functions. Async Rust is the second
Yeah.
of our 4 concepts. A trait is Rust's word for an interface. To implement the future trait,
Want me to put it
you
down?
need 2 things. First, an output type, what the future hands back when it finishes. Our sleep returns unit. Unit is simply Rust's way of saying a function returns nothing meaningful. Here, we only care that time
I've never heard somebody say unit, even though I learned Rust like 4 years ago from this guy only, but still.
has passed. And second, a poll method. This is the method that async runtime calls over and over to ask the future, are you done yet? Now, poll takes a couple of arguments, but the one that matters here is context. And the context is where our third concept appears, lifetimes. See this tick underscore? That is a lifetime annotation. Now, what does this mean visually? Lifetimes exist in Rust because Rust guarantees memory safety without a garbage collector. But to do that, the Rust compiler has to be certain that no reference is ever used after the thing it points to is deallocated. Now here's why the tick underscore syntax shows up. The context struct has a mutable reference inside of it, and anything carrying a reference inside has to declare how long that reference is valid for.
Yeah.
That's what a lifetime is. A
Fine.
label for the window where the reference is safe
I'm trying to think, why did he need unsafe?
to use. The tick underscore syntax here is an anonymous lifetime, which means we want the compiler to infer the scope where the reference is valid. The scope of the lifetime starts right here at the
Isn't that the default? If we don't give any lifetimes in that anonymous lifetime?
first curly brace. The moment poll is called and the runtime hands the
First scope, basically. Curly brace.
context in. And it ends right here at the last curly brace. The moment
Fine,
checked any
fine.
code that tries. Every reference and every memory access gets checked by the compiler.
Yeah, so what? I mean, this is a good way to explain it, but my issue is I don't know what get and check mute does. Right? My idea is that's probably an unsafe function that is returning, if it's probably just returning a reference and you're doing unsafe on it. I don't know. I don't understand this concept until I see what get and check mute does. I mean, I get the fact that getting an unchecked mutable reference is unsafe. I get that. But what I don't get is, what is the type of me? Who am I? I don't get it.
compiler, and anything it can't prove is sound gets rejected.
Yeah.
Unsafe Rust is a way to opt out of Rust's strict safety checks.
Know that.
It lets you run a small set of operations written in other
Show me the
languages.
function.
It is a promise from the compiler
Yeah,
that
I know that. Async function pin
at
mute,
this value
pin box time. All of
won't
those
move
things.
in memory.
But when do you have to do pin box time? When do you have to just do a pin reference? Because you have the
Why does pin matter here? Async futures can end up holding references to data stored inside themselves. If the future were moved in memory, those references would still point to the old location.
I just accepted the fact that it's pin. I never thought why it's called pin. It's called pin because async can continue to have references. Did not think of that. Dude, this guy is amazing. The best Rust resource out there apart from Rust links. Not
Making them invalid. Pin is what guarantees the future stays in the same place, so those references
Are you
remain
kidding
valid.
me?
Think of pin like a lockbox. The compiler has sealed your value inside it and is promising the value won't move in memory.
Okay.
If the value moved, those references would be left pointing at the wrong place. To actually reach in and mutate the value, you have to pry the lockbox open with the getUncheckedMutate method
Okay, sorry, my bad then. That's a method of pin. Pin provides you that.
inside of an unsafe block. The compiler can't verify you'll keep the promise that
I
you
don't know. I've never written unsafe Rust, so I didn't think of that at all. But yeah, it's coming from the pin. Great.
won't move the pinned memory, so it forces you to wrap this operation in an unsafe block. And this is the common pattern you'll see in Rust. One small, carefully checked line of unsafe, wrapped inside an interface that is completely safe to use. You write the hard part once, and everything built on top of it stays safe. And now let's put everything together. We started with this single macro. Macros, Rust Live Accelerator, we work directly with developers like you who want to master Rust at a professional level, use Rust at their current workplace, or land their very first Rust job. So if you want hands-on guidance,
Okay, cool. Dude, there's this book called Rust Macros book. I really want to read that. There was a podcast where the author described it, and it really, spoke to me. But I never, the little book of Rust Macros. This is the one. I really want to read this. I maybe do a stream on learning new concepts. That's probably a good one, and I'm gonna go through something like this and build something with Rust macros. Because the reason Rust is amazing is because of macros, dude. I mean, seriously, you have Serde, you have Tokyo, you have so many things that are just macros. Ascama, right? Okay, yeah, it's not easy.